Um, so, just talking with all of you today at the virtual class, uh, just a few things to wrap things up. Obviously, people wrote about related rates. I would certainly know the cone formula. Um, you know that. Obviously, Pythagorean's theorem in case there's a right triangle problem. Um, the volume of a sphere is 4/3 pi r cubed. Area of a rectangle, volume of a fish tank. Um, shadow. Remember, shadows, you got to think similar right triangles. Okay, so the height of the person is some number. Let's just say 6 feet. Let's say the length of the pole is 20. Um, dx dt is going to be moving toward the right angle, so it's going to be negative, and that's how fast the person's walking. The shadow is behind. It doesn't matter how far he is or she is from the lamppost, remember. That's like a misleading thing when they say when he is 10 feet from the pole or something like that. So kind of irrelevant. But your proportion would be s over 6, and then it's long to long, s plus x over 20. And then you cross multiply, and you get your XS relationship, and you're all set. And then your derivative is going to be to help you solve for the rate of change of the shadow moving behind. So in this case, you get this final answer, which you can use to find ds dt, or if you have ds dt, to find dx dt, etc. Somebody asked about shadow problems. Just remember with implicit differentiation, like, let's just take a simple one here. Implicit differentiation, let's say, we just have something simple like x squared plus xy plus y squared is equal to, let's see, 1 comma 2 is an ordered pair, so 1 plus 2 is 3, 3 plus 4 is 7. Okay, so if we take the derivative, recall that every time you differentiate with respect to y, you include a dy dx, not dy dt, dy dx, and then you solve for dy dx. In this case, it would be minus 2x minus y over x plus 2y. So that's pretty straightforward. And again, I don't know how possible, I don't know if this is going to be on the test tomorrow. But remember, now you have to plug in both the x and the y to find the slope of the tangent. So in this case, it would be negative 2 minus 2 over 1 plus 4. And that's your slope of the tangent. And then to make an equation of a tangent, you just use the ordered pair with the slope. And if they ask for normal, just remember it's a negative reciprocal. So just look at the notes on implicit differentiation too. Just keep in mind that nothing from Unit 8 is on the test tomorrow. So read Unit 8 from the College Board website. Just omit that section for tomorrow, okay? Rectangle approximation method, remember left, right, mid, or a trapezoid rule. If they give you a chart and you draw a quick plot and you get something that's concave down and decreasing, remember an LRAM is going to be an over approximation of the answer, and then an RRAM would be an under approximation, okay? And that's how you know. See, the under and over approximation is based on the concavity of the graph, and specifically if it's increasing or decreasing. So, again, plot the points on a quick piece of scrap paper tomorrow, and if you do that, you'll see that what is going to be an under approximation and what is going to be an over approximation. So don't get too bent out of shape with that. But approximating is a big topic that they do ask on the AP exam. I'd also keep in mind, based on what you guys said, I made a point with just inverse trig. I mean, you should know all the derivatives cold, okay? But then the one that really kind of sneaks up a little bit, I don't know if they'd ask this tomorrow, but just keep your notes and just remember that there are some formulas here for inverse trig, specifically for the inverse sine and the inverse tan. And remember, it's really associated with, and these formulas are in your notes, but like, for example, the tan of 1 in this case is pi over 4, like things like that. So I just make a point of that every year with inverse trig. Let's review just again one more thing, really the last topic, and you please check my outline of the things that I think they're going to ask. The 5 or 6 I would really focus on, and then like the next 5 or 6 that I think are topics that they might ask about. But anytime you have a position graph, let's just draw a sample position graph here. A particle moves according to this equation, and this is a 9-second path that a particle moves. So this is your S graph, okay? So keep in mind that in this case, the velocity, this is what the velocity graph is going to look like. These are all negative slopes approaching 0. This would be a very rough estimate of the velocity graph, okay? And then the acceleration graph, that's a little bit more, let's say a dark line, if you will. So you can answer all the questions that way about when a particle is moving right, left, and stop, and when the acceleration is positive and negative, and things like that. So drawing the graph is going to help you. If you have to make a quick sketch on the day of tomorrow, then do so. Also keep in mind that if you really are in a jam, if I have my velocity curve here, and let's say I make a quick curve and whatever, I'm just drawing something really quick. Let's say it's an 8-second particle movement problem. Then the speed is the absolute value. So if I were to draw the speed graph, it would look something like this, okay? And then from here, I can interpret if a particle's slowing down based on when the speed graph is approaching the x-axis. So I can think of it that way. In these intervals, the particle's slowing down, and then the particle's speeding up when I'm leaving the x-axis, okay? Keep in mind that you can also do that with a position velocity graph. If, for example, at time 4, the acceleration is negative, but the velocity is positive. I'm sorry, the position's positive. The velocity is negative, and so is the acceleration. So that tells me that I am speeding up at time 4. Whereas at time 6, my velocity is negative, but my acceleration is positive. So at time 6, I am slowing down. And it's important to know how to type into your calculator. If you have a velocity, type in the derivative math 8 to find the acceleration. And, you just got to know when to derive and when to integrate. That's really a big key to the test. Okay, and the last topic is really the differential equation concept. Okay, the differential equation concept. Just keep in mind that a slope field is really a very easy concept, and that's something that they might ask. Maybe check previous AP tests for like other small questions about differential equations, like, you know, find the second derivative, show it's concave down or concave up. But the key to any differential equations is separation of the variables. Okay, get the y and the dy on the left and the x and the dx on the right, and then you integrate both sides. Make sure you solve for c. Whenever, I would always solve it as earlier to better, and then solve for y with the c, and you will find that that's very straightforward. Differential equations, I would think that's a big topic. I mean, just to reiterate for the last time, and I'll feel free to email me, try to find some time tonight to talk, but I would really focus on diff-EQs. I would really focus on the fundamental theorem of calculus. I would really focus on speed, velocity, acceleration concept. First derivative, all parts, okay? How to find a derivative. Looking at derivative graphs and answering questions about f of x. You know, here's the graph of a derivative. Where is it above the x-axis? Then the original function's increasing. All that graph analysis with concavity and relative max and mins and things like that, I would definitely think that those are big topics, you know, for your test tomorrow. And good luck. I really want you to do your best, and I'll be around in the morning if you have any questions, and also you can email me tonight and anything you need. All right? All right. Best of luck. Thanks.